Hey there and welcome! Today we are diving into a really powerful tool that can take a totally confusing workflow and turn it into a crystal clear map. I'm talking about the UML activity diagram. If you've ever found yourself struggling to explain a complex process, you're going to want to stick around for this.
You know the feeling, right? We've all been there. You're trying to explain how something works, some multi-step task, and the words just get all tangled up. It's a super common problem, and it's exactly what activity diagrams were designed to solve.
So, what is an activity diagram really? Well, at its heart, it's a visual map of a process. It shows you what has to happen, and just as importantly, in what order. The best way to think about it is like a flowchart, but, a flowchart that hit the gym. It's got some extra features that let us handle real-world messy complexity.
Okay, so here's our game plan. First, we'll talk about why we even need these things. Then we'll get into the nitty-gritty, the how, by looking at all the core building blocks and the rules for directing the workflow. After that, we'll see it all come together in some real-world examples, and we'll wrap up with some pro tips so you can make awesome diagrams yourself.
So the whole point here is to visualize a process from its absolute beginning to its end. By mapping out every single step and how they all connect, we get to replace all that hazy ambiguity with rock-solid clarity. And this is so crucial for spotting bottlenecks, making things more efficient, and just making sure everyone on a team is on the exact same page.
Right, so if we're going to build these powerful maps, we need to learn the language first. So let's break down the core components, starting with the most basic piece of any process, the action itself.
The action node is basically the verb of our diagram. It's one single, specific task that needs to get done. Think of it like an item on your to-do list. Submit form, check inventory, send email. It's the fundamental unit of work.
And here it is. See how simple it looks? An action is just this rounded rectangle with a name inside. It's the most basic building block we have. Anytime you see this shape, you know a specific task is happening.
Now, a list of tasks isn't really a process without a clear direction, right? It's just a bunch of stuff. So, just like any good story, our workflow needs a definite starting point and a clear, unmistakable finish line.
And these two little symbols are what bookend our entire process. That solid black circle, that's the initial node. It's the green flag waving saying go. And the bullseye symbol is the activity final node. That's the checkered flag that says, all right, we are done. Everything that matters happens between these 2 points. So if we put it all together, this is what you get. The simplest possible activity diagram. The flow starts at that initial node, it moves to the check tank levels action, and once that's done, boom, it hits the final node and the process is over. Start, do, finish. Easy, right?
But of course, real-world processes are almost never a straight line. We're constantly facing choices, or we need to juggle multiple tasks at the same time. So now, let's look at the components that give these diagrams their real power, the power to model all that complexity.
Okay, this diamond shape is a big one. It's a critical control node that basically acts like a traffic cop for the workflow. It directs the flow based on specific rules, and we're going to see how it's used for making decisions and for bringing paths back together.
So first up is the decision node. The best way to think about this is like a fork in the road. The process arrives at the diamond, a question gets asked, and based on the answer, we call that a guard condition, it can only go down one of the outgoing paths. So here, if all levels are within tolerance, great, we head to the end. If not, we take the other path and sound an alert.
And this brings us to a really crucial distinction. A decision node is all about making a choice. You have to pick one path. But what happens if you need to do multiple things at the exact same time? Well, that's where the fork node comes in. It's not about choice, it's about concurrency, splitting the flow so things can happen in parallel.
And here is that fork. It's represented by this thick black bar. When the flow hits a fork, it splits and all the outgoing paths kick off at the same time. This is not a choice, it's a command. Do this, and this, and this, all at once.
So, after we split paths apart, we usually need to bring them back together. And notice, the diamond shape is back, but now it's a merge node. A merge just combines multiple paths into one. No questions asked, no waiting. But the black bar, which is now a join node, that's different. It's a synchronization point. It forces the process to pause and wait until every single one of those parallel tasks is complete before it can move on. Think of it like waiting for your friends to arrive at the theater. The movie doesn't start until everyone is there.
Okay, one last key distinction on how we end things. We already saw the activity final, the bullseye that stops the entire process. But sometimes you just want to end one single parallel path. For that, we use the flow final, the circle with an X. Think of it as a local stop sign, not the big one that shuts down the whole highway.
All right, we've learned the alphabet. We know the grammar. Now let's see how these symbols come together to tell a story, to map out processes that we can all recognize. This is where it gets fun.
I love this example. Making coffee perfectly shows off the power of forks and joints. You can boil the water and grind the beans at the same time, that's our fork. But you absolutely cannot move on to brew coffee until both of those things are done. That join node makes sure everything synchronizes up perfectly. It's a fantastic model of how things work in the real world.
And here's something a little more complex, a course registration system. A request comes in, and right away the system uses a fork to do two things in parallel. Check for prerequisites and verify the course isn't already full. Then, it uses those diamond-shaped decision nodes to handle the logic. Does the student meet the requirements? If not, do they have special permission? This diagram beautifully combines doing things at once with making smart choices along the way.
So now you have all the tools you need to build your own diagrams. Let's wrap up with a few pro tips, the key rules of the road to make sure your diagrams are clear, effective, and actually correct.
Okay, to make your diagrams really sing, keep these 4 things in mind. First, always know your purpose. These aren't just fancy flowcharts, they're for modeling complex behavior. Second, be consistent. All the actions on one diagram should be at the same level of detail. Don't mix high-level strategy with tiny button clicks. It'll just confuse people. Third, check your branches. At any decision diamond, make sure you've covered all the possibilities. Using an else condition is a great safety net for that. And finally, really get how concurrency works. Just remember, that join node is patient. It will wait until every single parallel task is done before it lets the process continue.
And this quote right here, it really drives the main point home. Activity diagrams are a sophisticated tool inside a much larger modeling world. Their job is to add a dynamic, behavioral view to things, to supplement other models, not to replace them with a simple old-school flowchart.
So, I'll leave you with this question to chew on. Think about your day, your work, your life. Whether it's your morning routine, a project at the office, or even how you plan a vacation, what's one process you could map out right now using these tools? I'd really encourage you to give it a try. You might just be surprised by the clarity it brings. Thanks for tuning in.